Okay, so let us discuss delete at end. We had already seen in the Jamboard how that delete at end worked. Basically, delete at end. Let me clearly draw a picture again. So let's say this is my head and I have some list. So when you have to delete at end, basically you have to start a PTR here and you have to keep moving and you have to stop at the second last node. You have to stop at the second last node. Okay, you cannot stop on the last node because the next of the second last node has to be made null. So you first stop at the second last node, that's your first point. Second, you can simply free it, that can be your second step. And third step is that you set this to null. The next of the second last node you can set to null. So that's your third step. Okay. Now there are complexities. The first complexity is, what if the list is empty to begin with? If the list is empty to begin with, deleting and does nothing, so it kind of returns happily because it has to do nothing. The second complex case is that if you have a single node, then there is no second last node. Okay, then there is no second last node, and this second last node approach doesn't work. So if you have a single node, life is still simple. You simply free the node and you set head to null. It is very simple to handle. Okay, so our pseudocode will be like this. If empty, handle it this way. If one node, handle it this way. And if two nodes, handle it this way. So that will be kind of our pseudocode. And let's look at our pseudocode. So let me just look at that pseudocode. Okay, so delete at end, here is the pseudocode. So our pseudocode is like this. If head is null, nothing to do, return, happily return. If head next is null, that means one node, then what do? I have written handle appropriately, but what you will do is you will do free head and you will set head equal to null. Basically you have deleted the only node and you have set head to null and you are very happy. Otherwise you start moving and you start moving till you get to the second last node. We had seen last time how we stop at the last node. We write code like while ptr arrow next not equal to null, keep moving. Now our logic is while ptr next, so we want to stop at the second last node, so we write next, while that is not null, we keep moving. And once you are at the second last node, life is simple. The next node you free and you set the next pointer to null. So it is quite simple. And this dangerous thing is no more dangerous because we have already handled the list with one node and we have returned appropriately, and we come here only if there are at least two nodes. Okay, I recommend using this return thing in favor instead of writing the else clauses. This makes the code quite simple to read and it doesn't indent to the right. Okay, so it's good. Although there are multiple return points and there are some people say that multiple return points are not recommended because if you have opened any file you have to close it in every return point, but I would kind of still vote that we can have multiple return points, no problem. So this is our pseudocode, and let's just go ahead and implement it. So how do I implement it? I start with this pseudocode. I have mixed C and English in my pseudocode because sometimes some things are accurately represented by C, so I use C, and sometimes I use English. So I will copy paste this whole thing in my function and I will start from there. Okay, so before even that I need to have the prototype. So delete at beginning, I can take the same prototype and I can have it delete at end. Okay, So now you may wonder that should it return the new head? Will the head change? Because I'm deleting at the end, so head will not change. So my answer is head can change. Head can change. If you have a linked list having single node, then the head will change. Earlier the head was pointing to that node, now the head will be null. If it was an empty list, head will not change. It was null and it is null. If it were more than one nodes, at least two nodes, head will not change. But I have got one case in which the head will change, so therefore I will return the new head. In case of the function display, if you see the function display, I have returned void because head will never change by display. Okay, so but in this case, delete at end, head can change, so I choose the function appropriately. Okay, good. So I have the skeleton, empty skeleton. I have the pseudocode. I copy paste the pseudocode and we start from there. So indentation is messed up, so again I will shift 91 to 110. I need to indent right. Always take care of indentation. A good indentation frees the brain to focus on the essential. Okay, handle. If head is null, great, return head, we are done. If head, okay, so this should be, yeah, if head next is null, then I need to free the node and I need to make head null. So what will I do? I will simply say free head, because that node has to go, because the only node is the node to be deleted, and I will say head equal to null and I will return head. Okay, return head. So that is also tackled well. If I have one node, I delete that node, head becomes null and I'm happy. So if we have at least two nodes, then so we can write the code like the comments matter. I recommend writing crisp, clear comments. It will help you. So make ptr reach the second last node. So that's what this block is doing, and this whole block I have written one liner that this is what the block is doing. Okay, it's making it reach the second node, and I have kind of said that yes, I am at the second last node. If that is the case, then the next can be freed and the next can be made null, and head in this case will not change, but I have to return the head, so I return head. And here this code should be correct actually. This code should be correct, delete at end. So let me just compile it, let's see. So okay, so I have some undeclared variables, ptr, let me declare semicolon. Okay, compiles. Okay, now I need to call it. So what I will say, initially I have these 4 elements. So what I will say is, maybe I will have a for loop again. I will delete things. So let me take a variable. I will delete 4 elements. Okay, so I will say for I equal to, in fact I will try to delete 5 elements. Even from an empty list I will try to delete, so that I will test everything. So I will say delete at end. Okay, delete at end head, and it returns the new head. I need to store it. Okay, so I will say deleting 1 element, and I'm calling this. So initially I should be seeing 40 going, so I will be printing the list at each step. I will say display head. I want to display the linked list at each step. So initially my linked list is 10, 20, 30, 40. After first deletion I should see 10, 20, 30, then I should see 10, 20, then I should see 10, then I should see empty, then I should see empty again. So if this code works, then I have tested deleting in more than one node, deleting in single node, deleting in empty list also. So let's see if that works. It gets compiled and let me run. So these are my initial contents. Deleting one element, I get this. Deleting second, I get this. And deleting, I am freeing the memory also. So Valgrind should be able to say that there is no memory leak. So let's check that also. And it says 5 allocs, 5 frees. That's very healthy, and 0 errors. So that's quite good. This means that there are no memory errors and there are no memory leaks. And by this logic, I have tested all kind of deletions. More than 2 nodes deleting single node, because when I deleted 3 elements, I was left with one list, right? When I had this list and I deleted, and I have also tested attempting to delete from an empty list, which is again empty. So that proves that this code is correct, and it is quite simple. The fact is, if you methodically think of all cases, all different options, and if you write the pseudocode initially, then you can very easily translate it to code, and whatever pseudocode you write is the base of your function, and some of it can convert to some comments, nice comments, and some of it, because you make C and English, some of it can directly translate to the function code. So that is delete at end.